In the sketch below, DEGH is a parallelogram. CD is equal to GF. CF is parallel to HP, and angle HEP is equal to angle HPE. Prove that A, CEFH is a parallelogram, B, CFPH is a parallelogram, and C, CEFH is a rectangle. Let's start with part A. Prove that CEFH is a parallelogram. Let's make it red. To prove that CEFH is a parallelogram, we need to prove that both pairs of opposite sides are equal, or that both pairs of opposite sides are parallel, or that both pairs of opposite angles are equal, or that the diagonals bisect, or that one pair of opposite sides are equal and parallel. Right now, we can possibly use any of these 5 ways to prove that CEFH is a parallelogram. So let's see what we have to work with. The question tells us that DEGH is a parallelogram. So let's make it green. DE sits on CE and HG sits on HF. We know that the opposite sides of a parallelogram are equal. So we know that DE is the same length as HG. So let's put a small green line on DE and on HG to show that they are equal. We also know that opposite sides are parallel. So let's put a small green arrow on DE and on HG to show that they are parallel. Sides DH and EG don't sit on CEFH, so these sides can't help us right now. So let's leave them for now, and we can take the green parallelogram out of the diagram. Now we have quite a bit of information about CE and HF. The small black lines over here and over here show us that CD is the same length as GF. So let's make a note, and we can say CD is equal to GF. We know this because this has been given to us in the question. We also now know that DE is the same length as HG. And as our reason, it is because the opposite sides of parallelogram DEGH are equal in length. Now, side CE is made up of CD and DE. So we can say that CE is equal to CD plus DE. Side HF is made up of HG and GF. So we can say that HF is equal to the length of HG plus the length of GF. Remember that if 2 equations are equal to the same value, then the equations themselves are equal as well. We know that CD is equal to GF, and we know that DE is equal to HG. So we can see that CE must be the same length as HF. We also know that DE is parallel to HG. And as our reason, it is because the opposite sides of the parallelogram DEGH are parallel. In the diagram, we can see that DE sits on CE and that HG sits on HF, which means that CE must be parallel to HF. Now we've proven that CE is equal to HF and that these two sides are parallel. This is enough evidence to prove that CEFH is a parallelogram. So as our answer, we can say CEFH is a parallelogram because one pair of opposite sides are equal and parallel. Prove that CFPH is a parallelogram. Let's make it red. To prove a parallelogram, we need to prove that both pairs of opposite sides are equal, or that both pairs of opposite sides are parallel, or we can prove that both pairs of opposite angles are equal, or that the diagonals bisect, or we can prove that one pair of opposite sides are equal and parallel. Now, CFPH only has one diagonal, so we cannot use diagonals as a reason. We also don't have enough information about the interior angles, so let's focus on the sides. On the diagram, we can see that CF over here is parallel to HP. So let's make a note. We can say that CF is parallel to HP because this information has been given to us in the diagram. We have one pair of opposite sides that are parallel. Now we need to prove that these two sides are also equal in length, or we need to prove the other pair of opposite sides are also parallel. Always keep in mind that we can use our answers to one part of a question to help us solve the next part. In part A, we proved that CEFH is a parallelogram. So let's make it purple. In a parallelogram, opposite sides are equal and parallel. We've already marked down that CE and HF are equal and parallel. So now let's look at CH and EF. These sides are equal. So let's put a small line on CH and a small line on EF. They are also parallel. So let's put a small arrow on CH and on EF as well. Now we can take the purple parallelogram out of the diagram. We are looking for a pair of parallel lines, and we now know that CH is parallel to EF because the opposite sides of parallelogram CEFH are parallel. From the diagram, we can see that EF sits on a longer line, EP. So if CH is parallel to EF, we can see that it's also parallel to the red section, FP. So let's make a note, and we can say that CH must be parallel to FP. On our diagram, let's put a purple arrow down here as well. Now in CFPH, we know that CF is parallel to HP, and we know that CH is parallel to FP. So we can say that CFPH is a parallelogram because two pairs of opposite sides are parallel. Prove that CEFH is a rectangle. Let's make CEFH red again. Now to prove that a quadrilateral is a rectangle, we need to prove that all four interior angles are 90 degrees. But if we can't do that, we need to prove that the shape is a parallelogram, and then we need to prove that one interior angle is 90 degrees, or we need to prove that the diagonals are equal. In part A, we have already proven that CEFH is a parallelogram, so we don't need to worry about proving that all four interior angles are 90 degrees. We don't have enough information to prove that any interior angle is 90 degrees. So let's try and prove the diagonals CF and EH are equal in length. Let's start by making the statement that CEFH is a parallelogram. We don't have to prove this again, so we can use the reason proven above. Now we need to prove that CF is equal to HE. CF is a diagonal, but is also a side of CFPH. And in part B, we proved that CFPH is a parallelogram. We know that opposite sides of a parallelogram are equal. So let's make CF and the opposite side HP blue. Now we can say that CF is equal to HP because the opposite sides of parallelogram CFPH are equal. Let's put a small blue line on CF and a small blue line on HP to show that they are equal in length. And now we can make our lines black again. Now remember that a question will not give you information just for the sake of it. This question tells us that angle HEP is equal to angle HPE. So in our diagram, let's make these angles blue. These angles sit in triangle HEP. So let's make the whole triangle blue. A triangle with two equal angles is an isosceles triangle, which means it also has two equal sides. So now we can say in triangle HEP, we know that HE is equal to HP. And as our reason, it is because these sides lie opposite equal angles. There is a small blue line on HP. So let's put a small blue line on HE as well to show that these lines are equal. Now we can see that CF is equal to HP and HE is equal to HP, which means that CF must be equal to HE. CF and HE are the diagonals of parallelogram CEFH. So as our final answer, we can say that CEFH is a rectangle because it is a parallelogram with equal diagonals.